Hello again, and welcome to our next video. Still talking about random numbers. So for this one, going off of what we will be doing or have done, depending on when you watch this, the Guess the Number program, we are going to start slowly trickling out a couple of new commands, which we'll fully introduce in the next 2 or 3 weeks. But we want to start evolving past doing the simple commands of like just print and input and variables. You can't obviously do too much with just those commands. So what I'm going to do today is a little experiment using the random numbers that we just learned, and also use some of the commands that we will do or have done already, depending on when you've seen the Guess the Number program. So I'm going to make a dice rolling simulator program, which is going to roll six-sided die lots of times, and it's going to tally the results. We got our period, the date, and name, and of course, because we're doing random numbers, we have that line of code from random import star. So for this one, let's say I'm going to roll a die. So D, there's not two of them, so like D1, D2 doesn't really matter here. So let's just do D. D for die equals int random times 6 plus 1. So once again, just a very simple six-sided die. 1 to 6 on the faces of the die. Now, one of the commands that is one of the most important commands in all of programming will be the if statement. It's going to say, depending on the outcome of the random number, do something. Okay, so the word if, and then we're going to say D. And I'm going to use two equal signs. Again, if you've watched this video after doing the Guess the Number program, we would have already talked about that. But there's a difference between, in programming, the single equals, which is for variable assignment, like we did in the line right up here with the D equals. But this is for checking to see, is the variable equal to something. So let's say it's equal to 1. We put a colon after that, we hit enter, and you'll notice that it's tabbed in. Again, we're just slowly trickling these out. We're not fully talking about them yet, but what this program's saying is roll a die, and if it comes up as a 1, do something. All right, well, what are we going to do? I'm going to make a count. I'm going to make a count of the 6 different outcomes. So I'm going to have a variable for the number of 1s, the number of 2s, the number of 3s, and so on. They're going to be called accumulators. They accumulate a total. If you did this experiment math class, you'd have a little piece of paper with tally charts, and you just scratch off every time you get a number. So if I come back up here, I'm going to say the number of 1s I have is equal to 0. 2s, 0. 3s, 0. So I'm making 6 different, apologies, 6 different variables which are going to be accumulating the tallies as we go. So down here, I have my random number. D is a random number 1 to 6. All right, so what happens if D is 1? Then I have one more 1. I have a tally chart of 1s. So the number of 1s equals the number of 1s plus 1. Now the way to interpret that line of code is, here's the value of the variable currently. So like right now, there's nothing. It's a 0. Then plus 1, it becomes 1. So then you're saying take what's on the right side of the equal sign and put it into the left. So the number of 1s is going to increment. It's going to go up by 1. That's a very common line of code. You're going to say take whatever it is, add something to it. Most times it's going to be 1, but it doesn't have to be. And then that's your new value. So it's like a little ticker. Tick, 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 tick. Every time you get a 1, it's going to add 1. I'm going to do that 6 different times. So 1s, 2s, 3s, 4s, 5s, and 6s. So if I come over here, I backspace because I'm no longer part of this if statement. It's just back to normal. And so if D double equals 2, 2s equals 2s plus 1. If D double equals 3, 3s equals 3s plus 1. And so I'm going to eventually end up doing that for all 6 of the different outcomes, 1 through 6. the key thing to understand here is the spacing in this case does matter. The fact that those are tabbed in means it only happens if that's a true statement. So if this is a true thing, then do this. For those of you that are in or taking geometry, you're going to learn or have learned the if statement. If something, comma, then do something. If the sum of the angles of a polygon equals 180, then it is a triangle. If it is raining outside, then I carried an umbrella. If D is equal to 1, add 1 to the number of ones I have. Okay, so let's continue. If D double equals 4, 4 equals 4 plus 1. Notice how I was consistent with my pluralization here. I made all the variables be plural. It's, one way or the other. So either make them all plural or make none of them plural, like 1 equals 1 plus 1, 2 equals 2 plus 1. I kept them plural because it's how many of them there are. So this program is not terribly different than the things we've done so far. You start with the input. Well, there's no input here. The computer's just generating a random number. So the input is really the computer saying, oh, what's the random number? Part 2 is doing the math. The math is, okay, let's tally. Let's tally how many check marks or how many little tick marks we have for the number of each die. And then the final part is show the results. So print, too far, there we go, print, I'll say quote ones equals quote comma 1. So once again, as always, like we talked about for the last 6 weeks, the stuff that's in quotes is printed literally, and then you have a comma separating the stuff that's printed literally, and then the output, the variable. I'm going to do that 6 times. If it seems a little tedious to you, welcome to programming. Sometimes you're going to have some tedious code. Now, I will also admit, for those of you that kind of know what you're doing or have looked ahead or have experience in programming, there is a shorter way to do this. We'll get to that much later. This is the long way, if you will. So I have a random number, I have 6 if statements, and I have 6 prints. Let me run this, and I just want to show you what happens. I will say, let's call this a dice roller, or something like that. Save it. Okay, so when we run it, it just rolls 1 die. Not very exciting, but it is random, and it does work. You have a 3. Let me try it again. But each time, because we don't have any kind of mechanism to say, do this multiple times, it's going to always give me 1 outcome, 1 die roll, 1 dice roll. So how do we do a whole bunch? Well, again, we're trickling these commands out. The if statement is a very important command that lets you make decisions or selections in your code. If this happens, do this. Another style of command is for repeating code, what we call a loop, making this happen a certain number of times. So there's a couple different kinds of loops that we can create. I'm going to use a loop, call it a for loop. Now, again, this is getting a little bit ahead of ourselves. For the moment, I'm not going to explain too terribly much about this, but I want you to just do what I'm about to do. So come down to the line of code right after we have all 6 of your variables, and then make a little bit of space. I'm going to type the following. For n, F-O-R, for n in range, parenthesis, and let's do 100,000, so 1 followed by 5 zeros, parenthesis, colon. Now, just like an if statement, the tabbing here matters. And as I keep saying, we're getting a little bit ahead of ourselves. I just want to show you some of these, before we start to get to them, so you can see that these exist. So what we're going to do now is the stuff that we want to repeat 100,000 times, I'm going to highlight it and hit tab so it's going to bump it over meaning that it's now it's in the same block as the for loop. So what I want to do is this. I want to say, take your mouse and highlight where you get the random number and all of the if statements. Now, what I don't want to get the ones that say print, because I don't want to print the results 100,000 times. That would be overwhelming. I just want to do the rolling and the counting, not the final outcome. The final outcome should print one time. So this code I have right here, where I have d equals all the way down to 6 equals 6 plus 1, I'm going to take that and I'm going to hit tab. Oh, but wait. When you hit tab, it doesn't really like that. Okay, when you hit tab, unfortunately, it pops up with a little pop-up thing. It doesn't really help. Hit shift tab. Okay, again, this is just stuff trickling out. Tab should tab over. Sometimes computers just do funny things. Hit shift tab. Highlight the code, hit shift tab, and now what you've just done is that all of that code that's over one tab is part of that 100,000 time loop. And then this stuff here where it says 1s equals 1s, 2s equal 2s, those are tabbed even more because they're not only within the for loop, they're also within the if statement. Again, if all of this is like, oh my gosh, what is going on? Trust me, we haven't gone over those commands yet. I just want to show you a little bit of a higher level program, just to show you, some of these future commands. So what should happen now, if I run the program, is I'm going to get that. And your numbers are going to be different, but that's because they're pseudo-random. They're random-ish numbers. You've rolled a 6-sided die 100,000 times. The outcome of each is 1/6. Now, with probability, it's not going to be perfect. Some are going to be a tiny bit more than others, but the more of these experiments we do, the more rolls you have, 100,000, a million. They're going to get pretty close together. So you can see here, 16671, 16708. If you take 1/6 of 100,000, you're going to get roughly each of those numbers. It's not like one of them is significantly more than the others. They're all about the same outcome. Again, I'm sure you probably have done a simulation like this in middle school or maybe like pre-algebra, algebra 1. But that's a nice little way to determine, using a couple of higher level commands in coordination with the random numbers we're doing. So one more time, let me just go through that program to show you what it does. So at the top, you need to import the random library. You have 6 variables that are set to 0. They're accumulators. They accumulate values. You have what's called a for loop. And n is basically a counter. You're saying, how many times do you want to do this? I want to do it 100,000 times. If you want to do it more, less, change the number. D is our die. It's 1 to 6. And then you have 6 what are called if statements. You say, depending on what row you got, 1, 2, 3, 4, 5, 6, then count one at a time, like a little tally chart. Once you've back-tabbed back to the far left, you're done with the 100,000 steps. And see how quick that went? Like if you were to do that by hand, it would go, it would take you forever to do that. But here, pretty fast. You printed out the outcomes, you have the text in quotes, you have the comma and then the variable afterwards. Neat little program. Thanks for watching. See you again next time.